So when we talk about the payload, what kind of payloads do you think that we can attach to the drone or attach to the drone? Or what is the payload actually?
Anything which the drone carries over and above its weight.
Correct. So anything which is additionally attached to the frame, okay, but is a part of the drone. Okay, so whenever we design the design of the drone is with considering the payload. So you can't build an aeroplane without considering the actual weight it is going. So when I'm designing the aeroplane, I will consider like whether it is a 300 seaters of aeroplane. I have to consider that 300 people weight also. Okay, with that aspect only I can design. Okay, so whenever we are designing a drone, we should design a drone considering what kind of payload it will be put up in future. Whether it could be a RGB camera, it could be a thermal camera, or it could be lidar, it could be a hyperspectral, multispectral, or maybe a speaker, maybe a flashlight, or maybe a fertilizer tank, or a cedar unit, or maybe anything. There are applications are endless about it. Like as we see it regularly, the utilization of the drone. Okay, so let's see what are the different types of payloads we can connect to the drones or what have been utilized. So there are basics of payloads, types of payloads, and payload applications. Okay, so there could be a visible light, there could be a night vision camera, there could be a first aid kit also, there could be a remote control loudspeaker. We have seen these two applications during the COVID times. Okay, there could be a remote control searchlight. So there could be a searchlight in form of like a rescue mission or search and rescue missions, what we normally do. So we need drone with a camera as well as we need a searchlight also. Okay, there could be a camera, high-end camera with high-end zoom and all this thing like 30x or maybe 50x zoom or 100x zoom kind of cameras are, would be there. Or even in your cinematography drones which are used, you have a very high definition cameras are there and all that things. Okay, then in your surveillance activities, like we may normally use infrared thermal cameras, or maybe a lidar cameras is also used. Okay, or lidar sensors are being used. So different upon the usage what you want to do, based on, like we are talking about the drone used in warfare. Like nowadays, even a grenade or a bomb, or maybe people are talking about putting a machine gun on the drone itself, and it fires the rounds. Okay, or maybe a missile on a drone. So all those things are payloads. Okay, so definition of the payload. Payload is the weight a drone or remote piloted vehicle can carry or unmanned vehicle can carry. I mean any drone which is the weight, additional weight a drone can carry. So whenever I'm designing a drone, for example, when I'm designing a drone, let's say each motor is capable of pulling 10 kg of weight. Okay, so if I design a quadcopter with that motor, so I will be having four motors. So when I'm doing a four motors, so my capacity of the combination of all four motors working together will give me a capacity to pull 40 kg of weight. Okay, but it is a formula which has been defined in a drone design, that you should always consider 50% of your thrust. Okay, so though your four motors together can pull up 40% of or a 40 kg of weight, you should always consider 20 kg of its weight. So maybe the overall weight of the drone could be 5 kg or 10 kg. So you can put another 10 kg on that drone as a payload. Like for example, my drone, AgriQuad drone, is having a capacity of 50 kg. Okay, it can pull the weight up to 50 kg. The motors are capable of pulling 50 kg, roughly around 48 kg. Okay, so if you see 48 kg is near about 50 kg for calculation, half of that half of that will be 25 kg. So my drone tank, along with the tank and everything, the weight is been designed in a such a way that it can take up the tank of 50% is 24.9. Okay? And that's why the drone class is in small class. See, tomorrow if I remove that 10-liter tank and I put a 16-liter tank, okay, my weight of my drone comes to 28 kg, 28, 20, 28 point something aa jata hai. So what would be the my total capacity of the drone? It is having 28, but my motor should be in position to capture to take the weight of the drone is how much? It should be 28 into 2. Okay, so I am not utilizing the 50% of weight ratio. I am actually overshooting the capacity. Okay, it is not advisable to have drone like that. So whenever you are designing, especially when you are designing a drone, you are going for a type certification, you should always build a drone such a way that you are along with the payload and your drone itself, the weight and the battery, whatever the things you are doing, when the drone is in air, it should be capable of pulling 50% of its actual thrust or the full load thrust. Okay, so like for example, if I'm having a motors, let's say each motor is capable of pulling 8 kg of weight or 10 kg of weight. So 6 motors, hexacopter will pull how much? 60 kg of weight. So I can build a drone which can pull up to 30 kg of weight. 50% of 60 kg is 30 kg. So I can build a drone such a way that it is capable either in a small class, or even I can go up to medium class, but up to 30 kg. So that means I can connect maybe a 16-liter tank also. That's But if I have a small motor, okay, maybe like a motor with somewhere 6 kg of weight. Okay, so 6 kg of weight, 6 kg का weight होगा तो कितना होगा? 6 into 6 will be 36. Okay, 36 का half कितना हुआ? 36 का half हो गया 18 kg. So your drone should not exceed more than 18 kg. So you should maybe connect a 8-liter tank or 6-liter tank only to that. Okay, so I'm just trying to give an example how you design the weight to the ratio of the drone. Okay, so it is usually counted outside the weight of the drone itself and includes anything additional to a drone such as extra camera sensors or package of that. So this is just a definition of the payload. Okay, what is outside the drone actual weight. Okay, but when you are considering the maximum takeoff weight, it is including with the payload. Okay, whenever you are defining the maximum takeoff weight of a drone, that is including your payload. Okay, so a lot of time you would see the payload which are attached to the drones, the camera sensors, or they are very very high end and expensive. Sometimes these payloads are more expensive than the actual drone itself. So a lot of time you will see this predator drone carrying a very high end optical zoom kind of cameras, the sensors, the thermal sensors, heat sensors, and sometimes even the lidar also. Lidars are also very expensive devices, or even hyperspectral or multispectral cameras are there, which captures the images in a different spectrums of the light and all. So in that scenario, your payload is more expensive than your actual drone also a lot of time. So you need to take extra precautions. So sometimes they are heavier also. Okay, so you need to design a drone specific to your payload also a lot of time. It's not that you can take any drone and just put a like in DJ and all the things you can connect small GoPros and all that things, and all that things is acceptable because those are very light or smaller payloads. But if you are having a heavy payloads and all things, you should design your drone accordingly. Okay, so it might all seems bit obvious, but here goes the higher power to the weight ratio your drone has, the greater a payload it can carry. Our drones with higher power to weight ratio are those couldn't carry 10 feet. Heavier drones will have some impact on the power required to carry payloads, big payloads, and you will see this payoff in flight duration possibility. Like I gave an example, like my drone, the AgriBot drone is built for 50 kg of weight. Okay, but when I'm attaching a payload, I am considering only 50% of its capacity. So I am putting what? A tank of 10-liter, which will, when filled with the fertilizer, it can weigh only up to 24.9 kg. Okay, so I am using within the limit. Assume that I remove that 10-liter tank, I put 16-liter tank, my weight of the drone increases from 24 to 28. Okay, so with my 10-liter tank, I am able to fly the drone for 20 minutes. but by adding a 16-liter of tank, I am able to fly only 10 minutes. If I increase the battery capacity also, like I increase a bigger battery or higher battery capacity, still I am not getting that efficiency. Okay, it may by right now I'm using 21,000 mAh batteries. I may think that okay, let me put 30,000 mAh battery. Okay, so I may get a more additional endurance or additional flight time. So if I connect 30,000 mAh battery, by connecting 30,000 battery, I am increasing the weight of the drone again by 2 more kg. Okay, so my earlier battery was weighing somewhere around 5 kg. Okay, but now it has increased to 7.5 kg. So my overall weight of my drone from 28 kg has also increased further 2 more kgs. So it has gone up to 31 kg kind of thing. So, see, the moment it is not just like by adding the more battery or adding more payload, your efficiency or drone flying will improve or increase. No. Okay, so that's what it's saying. You will see payoff in flight duration during possibilities. Okay, so you will lose your actually the endurance capacity, or you may lose your flight time. So you need to see how you balance out. So best option is to keep your drone weight along with the payload with maximum thrust whatever you can deliver to 50% only of it. Okay, that way you will get better flight options in your drone. Payload physics, you could always consider upgrading batteries. This is what I was talking about. Bigger battery means heavier payload, resulting with what you can include. It's all about the lift. You can have two drones of the same mass, one with larger. Again, a lot of people think that by just changing the propellers, like I can put a big propeller so that it will have, it can pick up the more higher weight of the drone and all the things. But you can't do like that. Okay, so whenever you are designing, let's say your drone is designed for to take 18-inch of propellers, you can't put their 24-inch of propeller because it may not fit to that particular drone also. The drone is, when the frame and everything is been designed, they are be designed in a keeping in a mind of some design aspects of the drone. Okay, the flying aspects of the drone. You sometimes the propeller may not fit properly to the frame itself also, and then it could cause lot of disturbance when flying also. It may not be stable also at that point in time. So we should always see that what is the best drone, what would be the right type of motor, right type of propeller, right type of ESC, the proper battery, what would be used. So all this, there is a engineering around it. Okay, so when the normally the drone designer or the person who designs the drone, so they calculate all these options. There is mathematics is involved when we are designing the drone. And then again, what kind of usage, whether I'm going to use it for surveillance, whether I'm going to use it for agriculture, or whether I'm going to use it for aerial photography, or whatever it is, or maybe a simple, I would say, there are drones which are used for like firefighting kind of things also. There where they will there is a drone which has been developed with a extinguisher attached to it. Okay, so if there is a fire at a very high altitude, you can fly those drones, and you can trigger the extinguisher from those drones also. So in that scenario also, it depends upon what weight it can carry, or what is that 50% ratio is managed within that. It's not that 3 kg ka extinguisher, I think that okay, I'll put a 6 kg or 5 kg ka extinguisher. No, if that particular drone is to designed to carry a 3 kg of extinguisher, you should put only 3 kg, not higher. Okay, until unless you have a drone which is capable of 6 kg and there you are reducing the weight, probably that will give you a better flight time. Okay, like maybe a extinguisher of 3 kg you can attach, so that may give you more flight time. Okay, but then again, you may not be optimally using your drone capacity to its fullest. Okay, so whenever you are using payloads or attaching payloads, you should pay attention to the weight and the flight time what it is being providing to you. Okay, gimbal, as we said earlier, it is used to stabilize the camera payloads that we have mounted on drones, and or maybe another autonomous vehicle such as UGVs. The gimbal integrates with IMU, so it gets the signal from IMU, and then basically it stabilize the camera, and you will have a very good footage either in form of a picture or in form of a videos also. Stable pictures or steady. Basically, the gimbal would be stable in both the axes. Either it is a two-axis gimbal or it could be a three-axis gimbal also. Okay, so you can see in the pictures These type of gimbals are available in the market, and you can also connect. DJI has their own set of gimbals, so a lot of time, especially in the DJI, you can't use any other gimbal, okay, until unless you are something engineer who can put that and fit that kind of things and all the things. Apart from that, then you have to go with their own set of accessories or equipments when you're connected. Okay, so what type of electro-optical payloads we have? Okay, we can have RGB cameras, we can have thermal cameras, we can have LiDAR cameras or LiDAR sensors, and then we have multispectral or hyperspectral cameras also. Okay. So what is RGB camera? RGB camera is nothing but whatever we see through our eye, the same is being captured by the camera. Like how we have a camera in our mobile, similarly the RGB camera what we connect to the drone, it could be a different type. Like most of the time I have seen the cameras what are being used into the on the surveillance cameras and all the things. Basically they use Sony camera. Okay, so most of the time they are using this drone because of the quality and the functionality what is required when you are flying the drone and capturing the pictures. That time you need to have the actual, the real what you see you should see in the picture. Okay, so human eye is sensitive to red, green, and blue bands of light. Most standard drones comes with a camera that captures the same RGB bands, so the image they produce recreate almost exactly what our eyes see. Okay, so that's why normally people prefer to use those type of cameras. Okay, so what is drone RGB? With RGB camera, your drone, you can see the entire field in one place by processing aerial imagery into a orthomorphic maps, quickly make observation, enter the geodata into the GPS, and drive right into the problem area without damaging your entire field. That means you can capture multiple images, process it into the softwares. Like for example, we are be using Pix4D software for generating orthomorphic maps. So we will capture a lot of images, almost multiple image overlapping images and all that things, and fit the data. Even the GPS points are being captured, and those are also fed into the software, and then basically it will create orthomorphic map for my further analysis or further observation. Okay, again, different types of pictures what you can capture through your RGB. So like mineralization, seed rate, soil organic matter, or denitrification zone. So based on the way we want to analyze, and we want to, like a lot of people do crop monitoring or soil monitoring kind of thing. Like I have taken my PhD thesis to work on the soil monitoring this thing. So I have put a proposal for my PhD thesis for soil monitoring, because that is the place where I have seen the farmers do not have access. The soil monitoring can only happen like you take the soil from your land, and then you take it to the lab. You get the report after 3 4 days or 5 days time, and then you come to know. So there is a lot of time is wasted and over. So we are trying to work where we will be flying the drone, and again you are taking a random sample from one particular place of your land. Okay, so you are not actually, maybe not your soil maybe not be uniform across the land. So you will not really know, or you will not able to find the real issue of in your soil also. So by using a drone and the multispectral cameras, we are trying to see the health of the soil. Okay, by taking the multispectral images of the particular soil, which will help farmers to better plan their the what we say crop, as well as the watering cycle, fertilizer cycle, or spraying, dusting, whatever is required for the particular crop and all the things, they can plan accordingly. Okay, so where the soil is more nutrient, where the soil requires more water, where soil may be having some issues or some need some corrections into that, or whatever it is. Based on that, the data, farmers will be able to take the decision, and they could probably do more better precision agriculture, or maybe improve their yield as they get more and more data. Earlier this data was not accessible, because a lot of time this kind of data was captured by a lot of agriculture colleges or the labs on their own, and they will take randomly the samples. Okay, but that randomness will not be very accurate also. So we are trying to bring that soil monitoring out of the lab uh, in a faster mode using the drones. Definitely, the traditional method will also be conducted on those soils during my study of research, where we'll try to compare, the traditional method of soil monitoring and the results what we trying to find out using the drones, and then we'll try to compare and make it such a way that it is matching or it is giving me the similar type of results or better results than my traditional way of soil monitoring. Got it? Okay, so what are the features of the payload? So software stabilization of the video stream, object tracking, video processing, steers the gimbal to maintain the object in the interest inside the video frame, even the object is moving and aircraft platform is moving. Like we see a lot of time application of the drones, in such a way that image stabilization. Like in DJI, we have seen this kind of like it try to keep the person in the into the frame of the picture, or it will follow the person. Like if the person is walking or he is running or he is actually cycling or riding or driving a car or whatever it is, it will try to fly along with the uh, moving object. Okay, the moment you lock a particular object or a particular face or particular person, it will keep on tracking, and that's how this cameras the cameras whatever we use nowadays, the RGB cameras with AI features and all the things, they have become more and more smarter. Okay, so the application of RGB sensors where we saw this, so traffic monitoring, like recently in our what is that, Kumbh Mela. Okay, so during Kumbh Mela in Prayagraj, IG Drones was the company who was given a contract by the government of India to monitor the crowd. Okay, so they used to fly the drones on regular basis, and then they used to capture the data, like how much people, like they were not actually capturing the face of the person or thing, but they at least they were trying to find out how many people's were there on that particular date at that particular location and all this. So rough estimation, like we'll always see 10 lakh people visited, 20 lakh people visited, 30 lakh people visited. How that numbers were coming, these numbers were coming more from this kind of data. So there are other ways to capture the data, but there was always correlation or some comparison was happening, like whether you may be having a ticketing system, or maybe you'll be knowing that how many tickets were booked, how many people have got into the hotels. There are various data was available, and then people used to try to compare with this amount of data also, or maybe a crowd monitoring, like movement of the vehicles. So this smart feature which is available now in the RGB sensors, where it can identify, we can train basically the RGBI for what particular object we are tracking, and then it will identify and give us the correctness of this. Like for example, if you see this may be a sensor programmed or trained to detect the car. So like the more the car is as per the shape, it will give you the percentage. So this car is showing 99%. Okay, but somewhere it has failed also. Like if you see this particular device, for it cannot recognize a big vehicle, that it is not like a car. Okay, so based on some corrections would be required in the training of this AI software and all the things. Okay, whereas here you can see this particular tempo, it is showing 89%. Okay, whereas most of the cars, whatever it is showing 99% or 98% kind of thing. But unfortunately, this particular location you see here, it is not actually able to detect. Whereas here it is only seeing the half of the car, it is just showing 80%. Maybe because it is not able to capture the complete picture of the car, the look of the car or something like that. So that's why it is showing 80% over here. Okay. So that's how your RGB cameras are become very smarter and all the things. So by having these smart RGB cameras, it could be become very useful in analysis and real time analysis. Like for example, like when we were doing power line tower monitoring, we used to get the data and we used to do post processing of the data. So when we finished the project, there was a phase three kind of project which was in discussion, where the power board was asking us that rather, uh, doing the post analysis of the picture, can we have flying of the drone, and then and there itself drone tells me, like as I'm monitoring. I am physically monitoring, or I am actually seeing the footage of the drone as I'm flying the drone. I can check, on my screen whether there is a nut bolt missing, or there could be a insulator on my power line towers may have broken, or maybe my wire would have got oxidized, or maybe a member bar is missing on the tower. Like this, some anomalies can be detected in real time and immediately report. So can we do that kind of thing? So they wanted a smart RGB camera to be fitted on the drone with AI ML feature on it, and so that in real time it will able to detect the problems. Earlier, what we do it, we just capture, because our camera was a basic camera. It was just designed to capture the images. So it was to capture the images. That images software, we used to put it into the software. Okay, all those images, 300, 500 images, whatever we used to capture, we used to put it into the software, and then software used to detect those anomalies based on the whatever the training I have done for that software. But in the phase 3, they wanted the camera itself to be a AI enabled, so that camera itself will able to pinpoint and show me exactly the way it was showing here. Like if I imagine this is the picture I'm seeing about the tower, it should able to show me then and there itself wherever there is a any missing or defects into the tower, like nut bolt missing, or maybe jumper member is not connected, or maybe danger plate is not there, number plate is not there, there could be a bird nest on the tower. So these are something which are the defects or problems on the tower itself. Or maybe insulator is broken, insulator is damaged, or maybe insulator is missing itself. So all these things would be what they wanted to find it in a real time. Okay, so we see the application of RGB sensors in disaster management. Drone can be used for fire detection, intervention monitoring, and also for post-fire monitoring also. That to just to analyze how much damage would have caused because of the wildfire and all that thing. So we can always do that assessment of the situation over there. Again, border security. This is another big aspect of the drone being used in usage by the defense. So you see the border is huge. Like if you see the northern border is very huge and hostile and very difficult to manage. And every part of the border you can't have a personal, or you can't have a post. Normally your post is not near to the border. Your post is almost like 2 to 5 kilometers away from the border. So you are always away from the border, but you send regularly people to monitor the status of your borders. So earlier, sending person physically was a big challenge. Okay, so every time you go, so a lot of time the people takes the advantage of people not able to monitor 24 by 7. Okay, so based on non-availability of personnel on the border, the cross-bordering transfer, or a lot of times, like right now, that even the drones are being used by the enemies to transfer the ammunitions or drugs, or kind of unwanted dangerous goods across cross-border transfer. So to keep a track of all these things, we can always utilize the drones. Okay, so because rather you going a person sitting 5 kilometers away, you can send a drone from here and you can just monitor regularly the movements at the borders. Okay, that will basically help lot of time, because sending a person coming back, sending back, that will be a very tedious and risky task for the military peoples. So sending a drone is always feasible and easier solution in this scenario. Okay, so again, RGB sensors, you can see it can be used for aerial surveillance, like it could be for windmill, it could be for power line towers, it could be for television towers, or it could be telecom towers, or it could be for even drones have been employed on the ship with the containers, or monitoring the external structure or the position of the ship with respect to the sea and all that thing. So a lot of time drones are being now deployed on the ships also, bigger ships and all, right? Just a minute. Huh? Okay, so what are the other applications of the RGB sensors? It could be monitoring of basically the asset inspection work, probably like solar farms, wind farms, railways, bridges inspection, power lines. We spoke about it, mobile phone towers, oil and gas, water pipes, building and construction, real estate, where we have seen enormous usage of drones on regular basis. Okay. So again, we spoke about the application of RGB sensors for mapping, the 2D mapping, 3D mapping. 2D mapping can happen using the fixed cameras, or 3D mapping can happen using the gimbal camera. So you can give a complete 3D perspective of that particular location or of that particular area also. And the person who sees these 2D or 3D images, they gives a complete different overview of that particular location. Okay, again in mining, erosion detection, boundary management, project progress monitoring. Like we have seen in real estate, like every month they will fly the drone and they will capture the progress of the particular real estate getting developed over there, or the building getting constructed and all the things. So even in the mining area also, how much stock is being pulled out from the particular mines and all the things, like coal mines, especially in the coal mines or wherever whatever mining is happening. Whatever the raw material comes out, that has been tracked using the drone, so which helps a lot of data analysis for the people, and give them the realistic picture about the stock. Okay, so apart from RGBA, there is another type of camera which is normally used. So whatever we can't detect, like basically the heat sense, okay, the heat of a particular body or object, which is invisible to human eye, can be detected using the infrared or thermal camera. So thermal imagers are also known as thermal camera, is essentially are heat sensors that is capable of detecting tiny differences in the temperature. So whatever the colors you are seeing, it is not actually measuring the direct temperature. It is actually measuring the difference in the temperature, and based on that difference in the temperature, it is creating that image over there. Okay, so the device collects the infrared radiation from the object in the scene and creates an electronic image based on the information about the temperature differences. Okay, so based on that minor differences, whatever it sees, it tries to create that image. So that this image is getting created because there is a minor differences in the temperatures, and based on that temperature differences, it will try to recreate that structure in a thermal image, what we call it. Okay. So what are the applications of the thermal payload? Originally, they are developed for surveillance and military operation. Thermal cameras are now widely used in regular commercial uses also, like building inspections, moisture installations, roofing, etc. Like I've seen a lot of time, there is a lot of leakages happening on the top floor. Okay, so thermal cameras are being deployed by a lot of builders, where they actually detect the from where actually, because normally you will see water coming from one particular location, but the source of getting water inside the roof might be some other place. Okay, so you have to track. So you will use a thermal camera to check the moisture and the heat, based on the way the heat differences is there on the roof structure. Okay, and based that way you will come. So you are basically, you are what we call, just a minute, I'm getting a call. Hello. I'm good. How about you? Okay. I'm audible, right? My actually system has got hung. Actually, I don't know. I mean, I'm only able to control the slides, but I'm not able to do anything else on my laptop.
No, you're audible.
Yeah, just a minute. Huh? Let me
Probably
see.
you can reconnect. That's used to happen to me quite some time.
This is first time it's happened to me. Anyway, I'll continue as it is going on. Once I am finished with the topic, then I'm maybe I'll disconnect. Okay. So we are talking about the thermal payload, building inspection, moisture, insulation, roofing, etc., firefighting, autonomous vehicle or automatic braking, skin temperature monitoring. We have seen this user utilization during the COVID times on the airports. They have put the sensors where it was able to detect automatically the skin temperature or the person's temperature, or industrial inspections, solar panel inspection where extensively the thermal cameras are being used, power line inspection we have used for a different purpose of a thermal sensor in our power line inspection, but it has also given a different perspective when we captured the images in thermal spectrum, okay, or infrared spectrum. So basically we were able to understand the material used for the power line transmission wires, okay. So it has given us a different view, and basically whatever the data we were captured, we shared it to the power board, and power board has given that information that some wires which were used were actually low standard wires were used, which were susceptible to the heat or these things, and that's why they were degraded over the period of time. Okay. So that's how we come to know, because a lot of times, like I'll give a very classic example. We did a small survey in Gujarat using RGB camera and thermal camera. Okay. So we actually did a survey for water pipeline. Okay. It was a small water pipeline with somewhere 2 meter of pipeline was there. Okay. So from the outside, if you take the pictures of the pipeline, it was very neat and clean. We do not know anything about the pipe, because from outside pipeline looks, but there was a lot of time we have seen, there were a lot of time the pipeline used to burst. There would be some leakages used to happen out. So what happens when the water is flowing inside the pipelines, the because outside of part of the pipes is the metal is subjective to the outside temperature as well as outside atmosphere conditions, whereas inside it is completely cold, continuous water is flowing inside. So a lot of time the corrosion used to happen. So as the water is continuously moving inside the pipes, some places there used to be corrosion, and very heavy corrosion used to happen. Okay. So internally you can't do much anything about it until unless you have some kind of a protection initially, but over the period of time of usage of water pipelines, your pipelines use get damaged from the internal. So you will not see a lot of damages happening from the outside of the pipeline, but inside of the pipeline would be happening because of the water, okay, the corrosive effect. So those were detected only by the thermal cameras. So you see the difference in the temperature. Okay, when we start taking the variation of the images on the thermal side of those pipes, we come to know there are some places we are seeing spots. Okay, so we just checked randomly those the water line water irrigation department basically checked those locations, and they try to open up those pipes and check what why these kind of image differences are there when we are capturing the thermal images. And we come to know that there was a huge corrosion happening at that particular locations. So it was bound that over the period of time that corrosion would increase and there would be a leakage happening into those pipes. Okay, so that's how we were able to come to know, um, uh, which was not visible to our normal RGB cameras, which was basically because of the thermal sensing. It was able to tell us where we have the problems. Even in wildlife monitoring, a lot of time these movements of the animals and all the things can be detected using thermal cameras and all. Okay, so wildlife monitoring also it has been immensely used. A lot of forest people are asking for drones. Like I had gone to Pinch, where they wanted to track the movements of tigers over there using the drones, using thermal cameras. So they have asked to, they were actually just asked to fly the drone and just to see how will be the thermal images would be coming. So we just did 1.5 day session over them, give them what could be done and all the things. So probably they can incorporate. So they were talking about setting up a team of rangers who can actually train to fly the drones and capture those images and all the things. But it didn't go further on. I mean, I didn't see any further thing coming up and all the things. Though we have given them a suggestion and proposal like what can be done and all that. Okay, so application of thermal payloads, building inspection, moisture insulation, roofing is what I talked about. Then firefighting, you can see the pipe, hose pipe, you can see here. Okay, and the building under the fire, you can see the difference in the color or the temperatures. Okay, even the autonomous vehicle, automatic braking, you can see. Okay, so it can detect uh, what could be the different types of vehicles could be used. Skin temperature we have seen, I told you about this, was very much in usage during the COVID times or during the pandemic times, where people were able to detect the temperature of a particular person, and then based on that they were confiscated or maybe they are put in a quarantine uh, at the airport itself. Industrial inspections also, a lot of places like solar farms, or maybe I have seen usage of industrial inspection in refineries, or maybe into pharmaceutical companies where you have a huge pharmaceutical plant, where they wanted to detect if there is any kind of leakage or any kind of things happening which is not visible to the normal eye. Okay, so they will fly the drone and they will try to capture the images, and then probably find out if there is any discrepancy or defects into their industrial setups. In solar inspection, I talk about. I mean, thermal camera with the on the drone. This is one of the biggest usage in the solar inspection panels. I mean, the bigger solar farms are being inspected using thermal cameras on the drones. Power line towers, I told about power line inspection and all things, right? Okay, so apart from RGB thermal, we see the application of LiDAR sensors. So LiDAR is nothing but light detection and ranging sensor, used light energy emitted from a laser to scan the ground and measure the variable distance. So what is the advantage of LiDAR? LiDAR is basically it. See, when you are actually trying to measure or create some LiDAR images, okay, so it may not be able to penetrate. Like you have a tree, you may have vegetation and all that thing. So in that scenario, you will not able to get accurate information. Whereas the LiDAR can penetrate that kind of vegetation and all things, and then it can capture the real image or right image and measure the variable distance. So based on all that data, it can recreate the complete 3D model of that particular location. Okay, so this data basically used is for variety of applications and by industries. Like I have seen lidar is used extensively in the agriculture field. Then even in the forest people are also using lidar. And then we have seen used in detection of the geological locations, or by geography survey of India people. They are also using it, lidar, for putting up the entire maps or the state data from that particular object, or maybe some archaeological site, or all that things. Okay, so basically earlier lidar was used on the satellite, but because of the drone, now you can put the lidars on the drone. But lidar are the very expensive sensors. Okay, they are very expensive compared to our normal RGB or thermal. So you will not see much of the drones with the lidar there. So there are only couple of them. Like in fact, we also had a requirement from the Bihar Power Board, where they wanted to have a footage of a tower using the lidar sensor. So basically, when the proposal was put by the board, they had put this request that we need to have a footage using RGB as well as thermal as well as lidar. So since we were not getting a drone with the lidar sensors, we could not provide that kind of footage. So we actually asked the board why did really they want lidar, and who suggested them for what purpose of lidar. So basically, there was before tendering process, they have asked couple of organization to provide the inputs. So one of the drone company has provided that you can capture the images using RGB, thermal, and lidar. That's why they have included the lidar. So we asked them what is that information they would see by using lidar. So they wanted actually during the monsoon or the post monsoon, lot of towers, you will see lot of vegetations growing around the tower or near the tower. So they want that to be captured. So that was a very basic requirement, which really don't require a lidar technology to be used. So we convinced the board that you really don't require a lidar to be used. The lidar to be used at a very appropriate or wherever you required those kind of sensors. Requirement was not meant for lidar. So I said we can use RGB camera over here and know whatever the vegetation is been grown over there. Basically, they wanted to see that whatever towers, wherever there is a vegetation of almost 5 to 6 feet of vegetation is grown around the tower, they could appoint a vendor to clean up the base of that tower so that it doesn't impact the tower. Okay. So again, coming back to the topic, so LiDAR, which stands for light detection and ranging, is a remote sensing technology that uses laser beam to get information about the surrounding object. Since its inception, scientists have used LiDAR to map the Earth's surface and acquire meteorological data. Okay, so you can see the image how it has been captured. So agriculture and forestry, basically, they are the two most important or the biggest industries which actually uses LiDAR to inspect the vegetation such as leaves, crops. Also, the above ground imagery, for example, forest canopy, can be removed to view the ground surface area. So based on the data, whatever there, based on you can create different set of images using your lidar data. Okay, so application of drones, we have spoke about this multiple times. The drones which are used not only from spraying the fertilizer or water, to react more quickly to the threats, weeds, pest, fungi. So you can appropriately put the pesticides or maybe fertilizer to save the time, crop scouting, validate treatment, action taken to improve the variable rate prescription in real time, which will help to estimate yield from the field. So that means you will have a better field. I mean, we have seen the farmer who are not using the drones and the farmer who are doing the crop farming using the drones has better yield compared to the traditional people who are using it. Okay, because he is utilizing, there is a lot of saving from other aspects also, like people who are doing a traditional spraying of fertilizer, they are end up spending more money compared to the people who are doing spraying using drones also. Like there is a tremendous savings in the money also, in the water also, as well as labor also, as well as the fertilizer also. Like in traditional way, we used to use 200 liters of water, 20 liters of pesticides is required or fertilizer is required. Whereas using the drone, we have seen it is just a 2 liters of fertilizer is required, and just 20 liter of water is required for 1 acre of land. Okay, so there is a huge saving. Again, that 1 acre of land, for a normal person to spray, sometimes it takes 2 3 days. Okay, whereas using the drone, I can do it in just 8 minutes, 8 to 10 minutes max. Okay, 1 acre of land. So think how much amount of the land I can cover using the drone in a day. Okay, uh, this is, as we spoke earlier also, that one of the application of the drones is basically the light show. So basically there is a, this type of drones are actually in probably a nano or micro category. They are very small drones. They don't have, they have just a small quadcopter, and they have a very good stable flight controller. I mean, it is very very lightweighted drone. Even the body, if you see, it will be made of a very plastic kind of thing, and then it has a base, and then it has a just four lights inside it. Okay, the RGB lights, it will be there. So every drone is like a 1 pixel. Okay, so they will fly. So there is a software which will be used, which uses the swan technology, and you program that software in such a way that when the drone flies, the drone is at the right position. So that 3D structure they will create in that software, and when it flies in the air, it will create those images which is visible from a very long distance. Okay, so this is one of the things which has been taken up uh, very extensively by a lot of OEMs or a lot of startups. Okay, in India also, as well as outside also. Okay, so far, any questions on the payload?
No?
Okay, so now we have two topics left out. Okay, just give me 5 minutes, maybe 5:51. We'll connect back at 5 p.m. I will just reboot my laptop. Okay, and then I'll connect back. Okay.
Okay.